Okay, here we go with the guided practice, which was on page 261 all the way to 262. You had to do problems numbers 1, 3, 5, 7, and 9. If you did it and you got the answers correct, or you think you did, here we go, let's verify. Number 1 is 5, number 3 is 0, number 5 is 3 pizzas, number 7, there's 2 answers. A was 20 pounds and B is $75. And for number 9, it is 30 inches squared. Okay, so if you got them all right, great. You're on target. Just keep studying. Do the problems again on your own without looking at the answers. See if you can do it again. If you got it wrong, that's okay. I'm going to go over it right now. And after we go over it, after you copy down the notes, study the problem, see how I did it, see if you can do it a different way. And then if you think you're ready, do it again without looking at the answers, yours or mine. And see if you really understand what's going on. Okay, but anyways, let's get started. All right, number 1. We have estimating each product, use a bar diagram if needed. Okay. I have a fraction times a whole number. We've done this before. Basically, you have to pretend you have 1/4. Right, that's 1/4, 1 out of 4. But the thing is, you have 21 of these. 21, if you had 21 sets of 4, right? And out of those 4, you only want 1. If you were to count up all those little pieces, how many of these little pieces would you have? And if you put them all back together to make whole sets, how much would you have? Okay? So, $21, right? So, let's think of it this way, if it might make it even better for you. 4 friends, there's $21. Only one of you is going to get the money, but it has to be divided equally. You're getting the money today, the other friends will get it some other time. How much are you getting today? So we have to divide 21 into 4 parts. But since we're estimating, I want to think of a compatible number, something that will be easy to divide, something that will be easy to cut up into 4 parts. Well, 20 is a multiple, and it's pretty close to the original number 21. So I'm going to go with 20. 1/4 times 20. I'm just going to go ahead and go right to it. Change that whole number to a fraction, put in a 1 under it. All right, so now we have 20 over 4. And again, a fraction is just another way of showing division. And the answer is 5. Okay, that's number 1. If I'm going kind of fast, I'm thinking after the got it's and the guided practice, if you've really been studying really hard, this should be making more sense by now. And by the way, there's no shame in watching this video twice, 3 times, whatever it takes, okay? It's here for you. So, there you go. All right, number 3. Same thing. 5/7 times 1/9. Okay. This time I have a fraction times a fraction. So they're both less than 1 by definition. They're both less than 1. So I have something less than 1, and out of that thing that's less than 1, I want even less than that. So it's going to be something that's even smaller than 1. Okay? I want a part of a part. Not even part of a whole, a part of a part. Okay? Now, this is where we go with benchmarks. Are we closer to 0, or closer to half, or are we closer to 1? Okay. Now, 5/7. 5/7, half of 7 is 3.5. Okay. 5 is somewhere here. Ooh, excuse me. Okay. Sorry about that. All right. Anyways, the denominator is 7. The numerator is 5. Actually, it's not that far away from 1, right? And like I said before, the halfway point would be 3.5. If it was 4, I'd say it's close to half. 5, we start inching closer to 1. I'm going to go with that it's closer to 1. Okay? So I'm going to put that over there as close to 1. Okay, now 1/9. Okay, now for this one, I'm not going to divide this by 9, or by 2, which would be 4.5, by the way. But I'm looking at the numerator. The numerator is just 1. It's really close to 0. So I'm going to say it's over here on this side. And I'm using different colors so you can see what's going on. All right. So 1/9, it's close to 0. I'm going to leave that there. This is close to 1. Now, what's 1 times 0? Anything times nothing is just 0. Okay. Boom. Number 5. It's a word problem, so let's listen carefully. Cyrus is inviting 11 friends over for pizza. He would like to have enough so each friend can have 1/4 of a pizza. About how many pizzas should he order? Jeez. How many should he order? All right. Again, this might take a little while, but just, again, we have 11 people. I'm just going to draw 11 stick figures just for the sake of argument. Okay, they're not very good. Don't judge me. But it's cool, man. Again, this is not an art project. I think I drew one too many. There, that should be 11 people. Cyrus is inviting 11 friends. So 11 friends. Yeah, just check something. That's crazy. Okay. And we want 1/4 of a pizza, okay? So, let's make sure I understand the problem correctly. He'd like to have enough pizza so each friend can have 1/4 of a pizza. About how many pizzas should he order? So, he wants each person to have 1/4 of a slice, right? Or 1/4 of a pizza from the looks of it, okay? So, again, it comes down to 1/4. I want this, how much pizza I want. 1/4 of a pizza for each of my friends. And if I have 11 friends, well, then how many pizzas should I order? Okay, let's check this out. So I'm dividing this pizza into 11 friends, okay? Or I want this 11 times. I want a compatible number. What number divides better by 4? 11? How about 10? What about 12? I think you can see that probably 12 works better, right? All right, I'm going to go ahead and change that to a fraction. All right. So it's like we're saying, okay, now let's pretend we have 12 friends and each pizza has 4 slices, right? How many pizzas should I get? Well, that pretty much tells me I need 3 pizzas, right? Okay, now some of you are like, wait, that doesn't make sense to me. All right, let me help you out here. Let me help you out here. I'm going to draw a visual. 1/4, right? I want everyone to have this much pizza, right? I have 11 friends. So one pizza has 4 slices then, according to the way I cut it. Right there is enough for 4 friends, right? Again, the 1/4, it's not saying that I only want this much pizza, because it would be impossible to cut this one slice into 11 people. Well, you could, but the slice would be really small. The problem here is suggesting if we had a pizza and we cut it up into 4 slices, I want each friend to get 1 slice. Now, if that's the situation, how many pizzas should I order? Now, what I did here was, real quick multiplication problem. 1/4, which is the slices I want, 1 out of 4, times 11 for each friend, 1 for each friend. So 1/4, 11 times. Right here, this is 1/4 times. But let's keep going with this. 1/4, here's my friend, another friend. That's 4 friends again. So far I have 8 friends. I need enough pizza for 3 more friends. Okay. Okay, that's 11 friends, right? But when you order pizza, you're not going to say, hey, I want 2 whole pizzas and 3/4 of another one. They're just going to look at you and laugh. Or on the phone, they'll just laugh at you, right? So instead of just ordering the 2 pizzas, you're going to order 3, right? Another way to see that the answer is correct, it's 3 pizzas. Okay? Guys, again, when you do math, it's not about how smart you think you are or how dumb you think you are. I keep saying this because at this point, some of you are like, I don't get it. Yes, you do. You're going to do this in your own life. Look at what I said again. Play it 5 times in a row if you have to. But let's just real quick review, and then I'll stop it. 11 friends. Each friend is supposed to get 1/4 of a pizza. So for each pizza this person orders, they're only going to get 1 slice if they cut the pizza in 4 slices. So hopefully you can see that each pizza gives me four slices. That's enough for 4 friends. 4 friends, 4 friends, 3 friends. I'm going to need 3 full pizzas. Okay? It's okay. If you just want to go straight to the drawing and figure it out, that's fine. Okay? Now I hope you understand why it's, even though it's not a full pizza, you're going to have to order 3 full pizzas. Okay? All right. That's enough for number 5. Let's go to number 7. Number seven. All right, here's the deal. You have to use this graphic. Might as well show it to you right here. Yes, the answer is there. So what? I already gave the answers earlier. So refer to the graphic novel frame for exercise A and B. I hope 5 bags is enough. So it looks like this person bought 5 bags of something. It looks like it says bird seed. I'm still a little picture of a bird. Yeah? Okay. So let's go with that. So if each bag holds 3 3/4 of a pound, estimate how many pounds of bird seed Elisa, Lewis, and Dwayne purchased. Okay, so I'm going to draw 5 squares. Or rectangles, squares. Why? Because according to the little picture I showed you, this person bought 5 bags. Okay, so bird seed. I'm just going to write the word bird. Bird. Okay. Bird seed. Now, each bag weighs 3 3/4 pound. 3 3/4 pound, 3 3/4 pound, 3 3/4 pound, 3 3/4 pound. All right, 5 bags. The question then is, how much does this weigh? By the way, I forgot to put pound, LB for each one, but you get the idea. I'll do it here so you can make up for that. So 3 3/4 of a pound for each bag of birdseed, right? That's how much it weighs. I want 5 of these bags. Okay, now this is one of those things where you have to do 2 things at once. Okay? Sort of. Not at once, maybe, but you are definitely going to have to do more than one thing. We have a whole number and a whole number and a fraction involved. A mixture, a mixed number now. A mixed number times a whole number. We didn't have that before. Okay? Well, actually, I think we did. Yes, we did. What am I saying? Let's break this down. 3 3/4 times 5. 5 is just 5 by its own. Now 3/4. We have to look at this. Is it closer to 0, half, or 1? Okay. Look at the denominator. It's 4. Numerator is 3. I'm really close to the denominator. I'm 1 away. So I'm going to say it's actually closer to 1. So that's 1. All right, 4 times 5, it's 20. So that means I got 20 pounds of birdseed. And again, an estimate, it's an estimate. So it's approximate, it's not exactly 20 pounds. Now, if you want to verify that the answer is reasonably close, what I told you before, look at the whole numbers. 3, 3, 3, 3, 3, and 3/4, 3/4, 3/4, okay. But let's just look at the whole numbers. I have 3 5 times. That's 15 pounds. And since this is close to 1 pound, 1 pound, 1 pound, 1 pound, 1 pound, that's 5, 15 and 5, 20. So you're close. Okay, the answer is about 20 pounds. All right, and this is part B. Let's do part B now. This is part A. Okay, same idea now. Here's my 5 pounds. I'm like my bird, don't worry. Each bag is $14.99, that's what we know. Okay, $14.99 per bag. Okay, so how much does it cost for 5 bags? So $14.99, $14.99 times 5. Okay, we're trying to work with compatible numbers. Compatible. I can, of course, multiply 5 times 9 times 9 and get this big old problem. Or I can find a number that works that's compatible. Kind of rounding. Instead of $14.99, I'm going to say 15. All right. So $15 times 5. If each bag is now $15, you can do the math real fast. 5 times 5 is 25. Carry the 2. It's about $75. Yeah? Okay. 10 plus 5, 10 plus 5, 10, 20, 30, 40, 50. Plus 5 times is 25. 50 is 25, 75. Don't worry if you don't understand that. If you did, great, but here's the work. You can see that I'm on target. All right, last one. Hope I have enough space here. All right, we have a rectangle. It's a really long one. We need to find the area. It needs to estimate the area. We have 9 5/8 inch and 3 1/4 inch. Now, in another problem like this, I already told you to find the area. You multiply the length times the width. So it's 9 5/8 times 3 1/4. Okay. I'm going to continue over here, but I will draw little benchmarks here. 0, half, and 1. Okay. 5/8. Half of 8 is 4. So 4/8 would be here. I have 5/8. 5/8 is 1 away from the middle. I'm going to say it's closer to half. Yay, finally we got a half. 1/4. Half of 4 is 2, right? 2/4. And 1 is real close to the middle, but here's the deal with that. 1 out of 4. I'm going to say it's if it's 1 away from the 0, I'm going to go with the 0. Yes, it's close to it's actually in the middle between the 0, 1, 2. It's right in the middle between 0 and the half. But, and I know I said earlier, it's better to go ahead, right? But in this case, it's 1 away from 0. Come on now. I'm going to say it's closer to 0. Now, if you disagree, that's fine. That's your right. Again, these are just sample answers, what I'm giving you, because with estimating, it can get really crazy. Okay? But anyway, let's see what we have here. So 9 5/8 times 3 1/4. All right. 5/8, we agreed it's close to half. Yeah, okay. Pretty close to half. 9 plus half. Yeah. Okay. Sorry. Just thinking to myself about something. Got a little sloppy here. Okay. So we have 9 1/2 and 3. Now be honest with me. Do you like that? I'm not liking it. 9 1/2. Now, since this is an estimate, I'm going to cheat just a little bit. The whole point is to make this easier. Now, is it really that hard? Not really. Because really what you're doing is 3 times 9 is 27, plus half 3 times would be 1 1/2. But you know what? Let's just make it 10. Okay? Look at that. 30 inches squared. Dun, dun, dun. So maybe I should have listened to my original advice earlier. If you're over the halfway point, let's go the next way. That would have made this easier, right? Because honestly, I was just following my own rules and the way I learned earlier. But you know what happens? Sometimes you have to change the rules just a little bit. It still makes sense. Let me rationalize that. 5/8. Half of 8 would be 4. And it's true. 5 is just 1 away from the 4. And really, you're closer to the midway point than closer to the end. So when I said half, I'm right. It is closer to half. 9 1/2 times 3. But in terms of math, making it easy, 9 1/2 is not an easy thing to multiply in your head. Okay? I mean, again, for me it is, but because I've done this for so long. But if I was at your grade right now, I'd probably, let's just make it to 10, right? Boom. 10 times 3, 3 inches squared. All right, and that is the Independent practice.